There is a small presentation from our sponsor, Mr. Rohit Nangia.
Hello. Yeah, Mr. Ramgure, you've said the blatant truth with so much on the lighter side. And since morning, we've been listening to the problems that we have. And there are many. We all are aware of that. Fortunately, we have a solution. So I would like to invite Prateek, Mr. Satish, come on the stage. So we are directors of a company called Fucoms, which deals in future composites. And we have an alliance with, our strategic alliance with a company called Nexcoms from South Korea. Fortunately, we have Mr. John from there who will be giving a small presentation about the solutions that are available in the world, which we can use for this country. And they have been using this surprisingly from the past 15 years. And we don't have it in this country, so I would like to invite Mr. John to say a few words, and I would be assisting him wherever required. Thank you.
Thank you very much. It is an honor for me to stand here and introduce a smart solution to the problem I've been listening to the whole morning with different kind of pictorial pictures of the problems, and I would like to just briefly introduce our solution to some of the problems that India is facing, and yet Korea also faced. Yeah. Okay. We see current scenario in India, the needs to reinforce and bring back life to the structural bridges, and current events of India. Next page, please. Or do I have to do that? Okay. We've seen enough pictures, so I don't have to go elaborate on this. Yeah, please. Next. Okay. These are current scenarios. Yeah. Okay. Do you wish we could have saved these bridges and buildings and people there? Of course. The answer is yes. Yeah. Next, please. And would it be nice if the occupants and the communicator at least had time to escape, reducing all the casualties or the catastrophic results. Yes. Now, please, next one. And if the strengthening of a building or bridge structure is merely a matter of days instead of months or years. So, next, please. And what if we already had that technology here? And we could apply it in India. And what if the conventional rehabilitation method that took almost 12 months to strengthen the bridges and buildings is replaced by a method which can be done within a month or two? Okay, next, please. Okay, we'll have a short film here. Yeah. So this depicts the overview of our product, and it's, yeah. So basically we use carbon fiber as well as glass fiber in the reinforcement. So we do, our fields are different, but I'll just go back to the base. The background of this technology evolving is in the 80s in South Korea, we had a major catastrophe of a bridge which is connecting the Seoul metropolitan city, which connects the two shores, and it collapsed. And it was a huge disaster in Korea. Then the government body has seen the need to strengthen the public law for these bridges which are weak. So this constant audit and all this public law has developed from the 80s in Korea. And we have been studying, like here's a brief view. In the 80s, steel plate reinforcement method was used. Carbon fiber sheets were used. And carbon plate reinforcement has been used. And now we use composite beam reinforcement method. See, if I'll just show you, this is a glass fiber surround and hollow aluminum which they will say CFRP, carbon fiber reinforced polymer, and glass fiber reinforced polymer has a very high tensile strength, as you all know. So our task was to use this as having 1800 megapascal of tensile strength and having maybe CFRP of 2000 megapascal of tensile strength has been a part of the plate reinforcement method. Now, what was the problem in that was when the load peaks to the maximum and the live load changes drastically, it would not show any warning between the concrete and the reinforcement beams or plates. Now, what will happen, we have studied over a period of time that it defaces from the concrete, and without warning, it'll break. Now, that would not be, for the government or the policymakers or the actual users of the facility, it is just not fair. So we do need a warning for safety of human lives. Because at the end of the day, why do we build this structure? For human beings, for facilitation and economical movements to be effective. So we have used the GFRP technology. These are four of our products. We have beams, reinforcement beams. Yeah, and what it does, and we have the column wrap also. So we basically, on the column, on the top and the bottom, we embrace the column. So, okay, so I'll go one by one. Okay, the reason, and we have made this into a 350 megapascal tensile strength. So one thing it'll never do, it won't deface from the concrete. When the peak load is applied, it'll sag along with the concrete. Now, giving it a fair warning to everyone to accept that warning and just evacuate and take the rightful measures to reinforce the structure. Okay, and another thing is this, another great, can we go to the next slide, please? Okay, these are the four elements, four material for the concrete, for the installation of our composite beam. The USP of our composite beam, as I told you, it becomes omni-entity with the concrete. That's number one for the safety issue. Number two, fast and easy installation. Now, we have the beams, we have the composite beams, epoxy, with a very, very high, we don't have details on this. And then we use the nail gun for not anchoring. We do not need any anchoring system. We just use it for curing. So it'll take maybe around 24 to 48 hours to cure. But our installation's done, we're out the door. Now I'll give you an example. In the underground metro tunnel, when we see pillars or columns are needs to be reinforced. So our men, within the 4-hour window of a metro operation, we did not disrupt the metro. Running of the metro, we go in, we install, we come out. Another thing is the weight. Can you imagine holding up a 7-meter steel beam to reinforce? What kind of machineries you'll require, manpower you'll require? Now, 7 meters of this, 2 men can lift it and install it.
So if I elaborate a little bit, these beams are approximately 220 centimeters wide, 7 meters long, and the way to fix it is just clean the surface of concrete, use the epoxy to paste on the beam to the concrete, use a power pin to just hold it in place till the epoxy is cured, which, like Mr. John said, from 24 hours to 48 hours max, and you're done. It just takes care of the whole thing at that time. And like he said, it's so lightweight that two people can carry a beam. So the example he was giving of the Korean metro, they are the only company who's been certified by the government of Korea to walk into the metro and repair it, because they have the operation times as so large that they just get a 4-hour window to go in, clean the surface, paste it, gun it up, and move out. That's the time they get. So this is the only product over there which is allowed to be used. Yeah, please continue.
Please, next slide. Okay, as he told, these are the steps how we install our composite beams. Yeah, please. Okay, these are the different ways that we can use reinforce the slabs as well as the beam of any sort. I mean, of course, bridges is another area that we do. Also, high-rise buildings or any structures, even masonry bridges that can be calculated case by case and then reinforced. Yeah? Next, please. Okay, these are different things, and then you have the data. I told you near about 350 tensile strength, megapascal, and these are some tests done. Okay, the application area, high-rise buildings, bridges, residential buildings, corporate commercial structures, and different things. And these are some of the works that has been done with our beams. Yeah? Okay, these are the wrapping plates that we have. Okay, we also see, as you see, we have, this is not on the water. So basically we embrace the top and the bottom. And these are also GFRP plates, a GFRP wrap, which is used with the epoxy. So anchor and bolt is not really necessary, but we can give the option of anchor and bolt also for the cost effectiveness. Now, where the beamway has to be faced on the beams or the slabs, we do not encourage any anchor and bolt, because that has a lot of complicated issues and all the technical machinery is required. So we do offer interlocking plate for fast installation.
So if I can just elaborate a little bit, please go back. Yeah, so these are custom made to the shape of the column. Any size, any shape can be customized. And they do not have, like he said, any pinning system to wait for the epoxy to cure. They have an interlocking base system between the two sheets, which you could just lock through. And if there are any gaps, you fill in extra epoxy and seal it off. So once they lock, they do not open up, because they've got this is like a cross section of the sheet where they lock into each other, and they've got teethings to hold each other and they can't come out. And once the epoxy dries anyways, it's one with the concrete structure.
So basically that's a nutshell about our product. But the one thing we believe in is there was an evolution of technology, as you all are aware of. There are armament, there are fiber fabrics, and there's on-site pregnation. But we see all these technologies evolving. Does not mean that India has to follow that technology, evolution of that technology. Why not, if you have an optimal technology, just embrace that, And one thing I realized, I've been trying to market and see the feasibility of this product in its market for more than 2 years now. So I'm more confident even after today's, especially after today's session that I had heard, that it'll have a huge innovative way of applying this into India's problem also. And I think it is an honor for me to actually introduce this product to you. So you can give us an opportunity also to see it. If it works, what have we got to lose? Yeah?
So since 2006, this is just like a chronology of works that these people have done. Please keep moving. So, okay. Some testings and all, which we could share with you, whoever is interested. We could show you all the test reports and how they've done it and the patents and everything. Fortunately, we are going to start manufacturing this in Noida. and it will be available in the market soon. It's gone for testings to IIT, so we are on the job on that. And what can I say? We were quite enlightened to see the quantum of concrete bridges that is available in India, which needs a technology like this. So, and if I speak from a non-engineering layman language, I would say that it almost doubles the strength of concrete once it's fixed. So we did a case study of a bridge where we got the data out and we studied it, we sent to them, they worked on it. And it was supposed to be a M30 concrete bridge. It's somewhere near Gwalior, and I can't share more details, but it's something like that. And the testing reports showed that the slab is behaving like a M17, M18 concrete. At places it was even M15. So once these beams were applied laterally every 1 meter, the net result was that, so they told me not to give it in written, but the calculations were coming as to that the slab was behaving like a M45. So they said, but don't share this. What you can say is M35 plus up to M40, because they need to take some factor of safety. So, but technically, as per the calculations, it was behaving more than M45. So
Sir,
we're
may I
very glad to
request-
introduce this to you. Thank you so much. Thank you so much.
Thank you very much, sir. So anyone interested, you can see our product at Demand. Yes?
Thank you.